This lesson's a fairly bizarre one. It's called function notation and identities. So we should know that log ex plus log ey equals log exy. Okay, why do we know that? Well, remember the rule is when common log bases or common logs with common bases are added together, what you do is you multiply the value being logged. So if f of x equals log ex, then this particular thing holds true. Okay, now what's it saying? So they want us to do, if f of x is that, okay, that's just saying it's log ex, that's f of x, and log e, so f of y means slam y into there, so log ey is the same as f of xy. So if I bang f of xy into the function, I get log e xy. And that's certainly true. Okay, so this identity holds true for this function. It also holds that if I've got a function log ex, take away log ey, it's the same as log exy. Okay, so we've got common base logs being subtracted. What we do is we divide the value being logged. Okay, so if f of x is equal to this, then this is the identity. Okay, so f of x take away f of y is f of x on y if f of x is that particular value there. So identities with function notation, our friendly examiner says, and that's Mr. Tench, says this is really important. Okay, so for the function with the rule f of x equals 2x, verify that this is the case for all x and y. Okay, so all we're going to do here is note that we want to do f of x plus y. Okay, so we're going to slam in x plus y into the function. So that's 2x plus y is equal to f of x, which is just 2x, and f of y, which is just 2y. Now verify that they are the same. Well, what I'm going to do is expand the left-hand side, and I've got 2x plus 2y is the same as 2x plus 2y as required. So this, okay, this identity here works or holds true for f of x equals 2x. Okay, for this problem here, we know that f of x is a hyperbola, and they want us to show that this is the case for x and y non-zero real numbers. Okay, so let's just note down that f of x is 1 on x, f of y is equal to 1 on y, of course, and f of xy is equal to 1 on xy. Okay, so what's f of x? F of x is 1 on x. What's f of y? It's 1 on y. And we've got x plus y multiplied by f of xy, which is 1 over xy. All right, so what should happen here is I'll be able to align these two. So I'm going to go multiply by y, multiply by y, multiply by x, multiply by x. And I've got x plus y over xy is the same as, if I multiply this out, x plus y over xy as required. Now, I don't know whether that's actually a show that, but basically for a show that question, we wouldn't be allowed to use what we're trying to show. But how am I supposed to know what I'm supposed to do with f of x if they don't give me some structure? So I don't know whether that would be actually a show that question, more like a verify or something like that. All right, for the function f of x equals e to the x, give the function identities for f of x plus y and f of x take y. All right, let's do the first one here. So we've got f of x equals e to the x. First one we're going to do is f of x plus is equal to e to the x plus y. And that's actually equal to f of x plus y is e to the x. Okay, and how do we get x plus y? That's common bases being multiplied, e to the y. All right, and now e to the x, I know that that's e to the x is just f of x, and e to the y is just f of y. So there is my identity there. F of x plus y is the same as f of x times f of y. All right, what about this one here? I've got f of x equals e to the x, f of x plus, whoops, f of x take y is equal to e to the x take y. Now that's equal to f of x equals e to the x over e to the y. And that's f of x take y equals e to the x is just f of x over e to the y is f of y. Okay, so there's the function identities. All right, so here is a typical exam question. So from the 2016 exam, judge function versus show that question. So this is what we need to do. So the function f has the property where this is true for all non-zero numbers. Which one of the following is a possible rule for this function? Okay, so let's try it out. So what we're going to do is go to the catalog and judge function is what we want. All right, or I should have done this before. Let's define our first function, f of x equals x squared. All right, so now we're going to judge. And what we're going to do is put the identity as it appears in the question. F of y equals y take x multiplied by f of x times y. Right, now notice that if it's not true, and this is really important to note down, so put this down in your notes, if it's not true, it says it's undefined. All right, so now what I do is for this question is I just simply update it with the next function in the list. So I look at option B and redefine the function. And it still is undefined, so it's not true for this function. Right, then we'll go x times ln x, undefined. Hopefully it's coming up, 1 on x. It's true. Okay, so this judge function, when it's not true, it just goes undefined. Wouldn't it be nice if it said not true? But anyway, it says undefined. So when it's true, it tells you it's true. And there's my answer, D. Okay, so these questions, they come up all the time. Okay, I don't know why they ask them. They're crap questions, to be honest. But yeah, it really can be rote learned. You just roll through the questions and define it, and it's done. Okay, there's a worksheet, and question 10 in particular is pretty brutal. Okay, so what a function f satisfies the functional equation f of xy equals f of x plus f of y over x plus y. And we know that this is the case. So f of 1 equals 1. We want to find f of 2, f of 3, and f of 10. Okay, so f of 1 equals 1. F of 2 equals f of 1 times 2. I'm allowed to say that because that's like 1 times 2. And then I can say that if this is x and this is y, let's go let x equal 1, let y equal 2. Okay, so now that I know that, what I'm going to do is use this functional equation, and I'm just going to have a crack at it. So I've just got f of x, y, and these are the values I'm going to use. So f of 1 times 2 is equal to, all right, now f of x, okay, so that's going to be f of, in this case, x is equal to 1, plus f of y, okay, which y is equal to 2, okay, noting that I've just let those values be the case, over x plus y, which is 3. All right, so I'm just going to transpose this now and say that's going to be 3, and 1 times 2 is 2, so 3 f of 2 equals f of 1 plus f of 2. All right, now I actually know what f of 1 is. That's just 1. So that's 3 f of 2 equals 1 plus f of 2. Now remember, what I'm trying to find is what f of 2 is. I've got 3 lots of f of 2 here, and I want to subtract 1 lot of f of 2. So I've got 2, so I'm just going to continue this up here. 2 lots of f of 2 is equal to 1. And that means f of 2 must be a half. Okay, so I can conclude that f of 2 is equal to a half. So I found f of 2. I've got f of 1 already. So now let's get f of 3. Now the way I'm going to write that is f of 1 times 3. Now why 1 times 3? I already know what f of 1 is. That's 1. Okay, and I'm going to use basically the same process that I used before. I've got f of 1 plus, not times, so I'm putting that into the identity, f of 3 all over 4. All right, now what's that going to be? It's going to be 4 f of 3 equals f of 1, which I know already, plus f of 3. Subtract f of 3 from both sides, and I've got 3 f of 3 equals 1. F of 3 equals 1/3. All right, f of 10. Any chance you can think of what f of 10 might be? I'm going to suggest to you that f of 10 is going to be 1 on 10. Let's just quickly try it out. F of 10 is 1 times 10. Remember, I can use 2 times 5, but why would you do that when you know the only thing you know is f of 1? Although, you know what f of 2 is? F of 2 is actually a half. So you could actually do 2 and then work out 5, but let's just go with what we already know. So f of 1 times 10 is equal to f of 1 times f of 10 all over, what are we doing? X plus y, which is 11. We've got 11 lots of f of 10 equals 1 times, it should be plus, and I don't know why I put times there. Make sure you correct that in your notes. F of 1 plus f of 10, which is 1 plus f of 10. We're going to subtract f of 10, so we've got 10 f of 10 equals 1. F of 10 equals 1 on 10. Right, so here's the hard part. Find the rule of a function that satisfies this. So if I know that f of 1 equals 1, f of 2 equals 1 on 2, f of 3 equals 1 on 3, f of 10 equals 1 on 10, then f of x is simply going to be 1 on x. Okay, it's a hyperbola that satisfies the equation. Now that is excruciatingly hard. Okay, I remember teaching this problem for the first time many years ago and really struggling with it. Okay, and it really requires you to understand exactly what I've done in this step here. All right, it requires you to unpack f of 2 a little bit and to then use this process. Okay, but yeah, extremely challenging problem, no doubt. All right, so you're going to do exercise 7D and a sheet with functional equations. There's also going to be a VCAR worksheet. I think that might be one and the same, but I can't remember. I haven't taught this for a year, so haven't thought about it since then. But yeah, oh yeah, there will be a VCAR worksheet on top of that. The sheet involving functional equations, I've just done question 10. 9 is pretty tricky as well from memory, okay? 1 through to 8, they're just like, yeah, smashing this, and then they launch 9 and 10 on you. So this one was question 10. Question 9 is also challenging.